Good evening, everyone. My name is Engineer Liu Adekunle. I will be taking you advanced reinforced and pre-stressed concrete design. Um, for this week, I'm going to look at major and minor axes of the column. So, firstly, I want to look at what is column. Columns are vertical compression members, and they carry secondary bending moment about the major and the minor axes, or about the both axes. Now, before we go further, we're going to look at some terms that you will need. Now, first, we're talking about major and minor axis. What is major axis? What is minor axis? We need to look at that. And before we can consider that, we are going to look at what is axial load. Now, when we say axial load, that is a force that has its resultant moment or its resultant passing through the centroid of a particular section and is being perpendicular to the plane of the section. So what I'm trying to say is that when we load a column, we all know what a column is in Latin, that you refer to as maybe pillar or whatever it is. So when you load a column, depending on how you are loading it, the force you are applying on that load or that column, that's your axial load. And that is the summation of the force. However, there's something we call concentric load and eccentric load. Now, when you are applying the load directly at the center of the column, then you refer to it as concentric load. That is, it is concentrated at the center. However, if the axial force is not acting through the centroid of this member, then we refer to it as eccentric load. Now, since columns are predominantly carry compressive forces, then they are referred to as compression members. That is, they only carry forces, so they are referred to as compression members. Now look at this. Look at what we have here. We have this column in this figure 1. You can see we have axial load. This axial load P is acting at the centroid here. Now when it's acting at the centroid here, you can see that means the beam and the column is axially loaded. However, it is possible for it to be uniaxially loaded. That is, it's going to experience bending in one direction, maybe X or Y direction. However, looking at this one, the loading here is acting on this line X here. So, and it's not it's at the point 0 of the Y axis. So this one is acting uniaxially. That's why we have it's only having one eccentricity, which is ES. But if in a situation whereby it's acting at this point, maybe the loading on your column is acting at this point, you have it you have at a certain distance of Y axis and at a certain distance of X axis, then we say it is biaxially loaded. Now let me go further. So as a axial load with uniaxial bending, axial force P is not acting on the centroid of the member. It is said to be eccentric. Now, due to eccentricity, a moment will develop in any one of the axes of the column. Because when imagine somebody carrying a bucket at the side of his head, the bucket will tend to tilt. But when it's balanced at the center of the head, the bucket will stand. Now, axial load with biaxial bending, that is when the axial force. Okay, let me look at. I believe I've explained what is uniaxial bending and biaxial bending. Now, I said in the uniaxial bending that the actual force is not acting on the centroid of the member, though it's said to be eccentric. Now, this eccentricity is on one axis, maybe either on X axis or on Y axis. It takes place only on one axis of the column. So that is why you have it as uniaxial, that is one axis. That is why uniaxial bending. But when we have it in biaxial, that is in true bending, axial load with that is true double axial bending. That is, the axial force P is not acting on the centroid of the member. It is said to be eccentric, and due to this eccentricity, a movement will develop in both axes of the column. That is, the moment will develop in both the X and the Y axis, and bending takes place in both axes of the column. When the loading is at the centroid as shown in figure 1a, it can be treated as axially loaded column. This is figure 1a. When the loading is at the centroid, it can be treated as axially loaded column. However, when loading is on one of the axis of the, as shown in figure 1b, you can see it's only on one axis x, then it is treated as uni-axial loading. Now, when it is on both x and y axis, as shown in figure 1c, it is referred to as biaxial. That is, it has moved some distance away from the centroid in the x axis and some distance away from the y axis, as you can see here. So that's why we have it as biaxial bending. So now let us, having understood this, now let us look at how do we find the major and the minor axis of a column. For instance, we were given this column, that this column is let's say it is 400 by 200 mm, and we are to find the major axis and the minor axis. As you can see here, how do we find the major axis? How do we say this is the major axis? How do we say this is the minor axis? So what we are going to do is that we calculate our moment of inertia, which is our IXS and IYY. You all know your moment of inertia for a rectangular column or a rectangular section. We have it at BD cube over 12. So our B, which is breadth, is 200. We are given breadth of 200, and our D, which is 400, we calculate it along the x-axis and along the y-axis. So you can see that there's a difference here. When we are taking x-axis, we are using B as the single term, but when we are taking it as y-axis, the D is the single term, while the B is a cube. So now, having calculated this, we will now check this value of IXS, our moment of inertia. Which one is greater? Is ISS greater than IYY? If IXS is greater than IYY, that means our IXS is the major axis. That is, the highest between ISS and IYY is referred to as the major axis. Please don't forget that. Now, the class task is that I want us to practice something. Firstly, I want us to look at this section we have here. I want you to calculate the major axis. This task A. Calculate the major axis and the minor axis of this column in figure 3, this column that we're having. Given that the column is 200 by 450 mm, that is, your B is 200 mm and your D is 450 mm. So I want that task done, and I will check that the first thing before in my next lecture. I will check it. I want each and individual one of you to check. If there's anything you don't understand, you can put in the comments, or if there's any other something you want to ask, you can put it in the comment section, and you can also ask me questions too. But please, on the YouTube platform, or sorry, on the WhatsApp platform, I will want us to be to restrict ourselves to only questions that are relevant to this course. And I want to try as much as possible to make this course to be easier for everyone to understand. If there's anything you don't understand, kindly let me know so that I can go over it and I can explain to you. Because I don't think wasting my time, one should waste time in teaching and you won't understand. And this is the beginning section. I want everybody to participate, to understand, because I can pinpoint anyone in the class that, can you explain this to me? Can you do this? And if you are not able to do that, then I will be forced to penalize you. But I'm very sure we are brilliant students, and I'm sure that we can do our best and we'll all understand what is being taught in this class. Now, conclusively, the axis which is perpendicular to the depth of the column is termed as the major axis, while the axis which is parallel to the depth of the column is termed as minor axis. Now let us look at this axis of bending. When we say axis of bending, for instance, when our wind load acts on a member, as you can see this F, how do you think this member will bend? When this force comes on this member, on this column section, it tends to bend in this, it tries to bend in this direction. and that's why our major axis here is treated as y axis. And um, and what if parallel is coming like this, then it's our minor axis is at y axis, but this is a different dimension, and but this might be a little bit let me say difficult for some people to understand. But with the understanding of what I explained here the other time, I believe everybody can calculate the maximum and the major and the minor axis, and you can always use that one for understanding. Now, what we have here is a beam and column layout. When we say beams and column layout, I'll be talking about axial load, biaxial load, uniaxial load. How is this applicable in our building design? Where is this applicable? When can I use this? When can I use this? When can I use this? Now look at what we have here. I have this is a sample of a plan, and I have different columns. Column C, you can see different columns with different colors that I have here. All these ones are columns at those joints. Now, when I have a column like this, the first thing to consider is what's the distance here, what's the distance here, what's the distance here, what's the distance here, what's the distance here. Now for this particular one, they have this NMC, they are equally span 3.6 meter and 3.6 meter. So this one, it might look very simple for when I want to consider this particular column, this C1. Okay, before, just look at this, then let me make some explanation before I go to it. I said practically the pure axial force in the inside column is a rare one. That is, there will be a bending moment due to difference in wind loading. Due to the rigid frame action, lateral loading, and practical aspect of construction, there will be bending in all the inside columns too. So what I'm trying to say is that though we are having something like this, we are saying that we are treating it that okay, in this place everything is the same. That the load are being concentrated at the center point of this, because the span here is the same, the span here is the same, the span here is the same, the span here is the same. But in reality, at times it might not be. Let's say it might not be perfect that it will carry the same loading like that, because if you when you cast your load, maybe your beam 3.6 meter, maybe is, even though they are the same section, there might be a little shift in load, or one might be a little bit bigger than the other. So this critical condition can only be practical in let me say theoretically, but in practice it is always very rare. Now for this particular one, I said the side and corner columns we have share along with axial load and bending moment in one or both direction. Now, what the first question I want is that the side and corner columns. This is the side column, corner column. These are the corner columns. These are the corner columns. C3 are the corner columns. The side columns, we can talk about C2 and C3 being the side column, while C1 and C1 is the internal column. Now, all the internal columns are treated for axial force only. That is, these ones, they are treated as axial column, axially loaded column. That is, the load is acting at the centroid. Now for this particular one, the middle columns in the end row will be designed for axial load with uniaxial bending moment. Where are the middle columns? This one, this one, this one, this one. That is, they will be treated as uniaxial loaded column. Why? Why are they treated as uniaxial bending? Let me say, treated with uniaxial bending moment. If you look at this, we can say okay, the moment here is being balanced by this moment here. However, this load, there's no continuation and there's no continued moment to balance this other side. So there will be a moment in this particular section, because the load there is not having a counter load to support it here. But if for this and this side, this one is balancing this side, so this side is settled. So for this one, it is having only one axial, one uniaxial bending moment, because there's only you need a single span of column or of beam to support to balance the moment on this column here. But however, let us look at corner columns, this C3. Imagine we have it loaded this way, loaded this way. Firstly, we will need a moment, we need a continuous beam to support it here, and we need another one to support it here, making two beams to support it. That is, there will be moment with respect to this loading and another moment with respect to this loading. That means we will have biaxial bending moment. So I said the corner columns will be designed for axial force with biaxial bending moment. Now, this is only practically applicable because of the similarity of spans. Else, the structure needs to be analyzed for given condition. What I am trying to say is that what we have here is only, why I'm saying so is because I said they are uniformly spanned, or they are symmetrically loaded. That is, this span is equal to this span and the beams are of the same section. So if I say 3.6, 3.6, we can always that's when this one and what I said is applicable. However, if this one is maybe 3.6 and this one is maybe 5 meter, then it will not the condition might change. So I will want you to have the class task B. The figure below is the plan of an office. You are to determine the column categories design as maybe axially loaded column, or it is column that is subject to uniaxial bending, or it is column that is subject to biaxial bending. Then also the direction of the slash spanning are also shown. So just like what I have here, this is the class task 2. I want you to do this, and we take this one to next week. If there's any question, let me know. So you read more on this. Then this is the spanning, this is the x and y direction. So the spanning for this and for this, and you can see the span 3.5 meter here, while this one is 4 meter. So I want it treated. If there's any question, I will not want to go much into that. Let me just stop at this particular place. Let me see what you have for me. If there's any question, I say you can drop your question, practice it, read ahead of me, because I will be asking you question. If there's anything you don't understand, go online, check, then come back with your question. And I believe we have done some things today, though even though today is supposed to be introductory class, but I will want you to just know that I've treated axial load, uniaxial bending, biaxial bending. So in my next lecture, today I've treated major and minor axes, and how to get the direction of your bending, and I want you to treat this. This is the welcoming party for this particular course. The next lecture that we drop, I don't want it to be more than 20 minutes. So the next lecture that we'll be dropping, I'll be treating how to design this our column. So I will be treating how we design this biaxial bending moment and some other things. So if there's any question you don't understand, please kindly let me know, and I think I might crop some notes for you people, so that you have something for you for this week. So please drop your comments, and I wish you a wonderful night. Thank you.